All right, welcome back. We are jumping into chapter 6 now. You should have already gone to school and picked up your packet for these notes. If you have not, take these on a separate piece of paper and then make sure you go get that note packet as soon as possible. Okay? So 6.1 is going to have to do with polygons. So, angles and polygons. All right, so the first start thinking part says, what is a polygon? Draw an example of a five-sided concave polygon and a five-sided convex polygon. So let's just talk about what a polygon is. A polygon is going to be a closed plane figure with at least three sides. Okay, what does it mean to be closed? Here is an example of something that is not closed. See how it's not closed? And then here's an example of something that is closed. It doesn't have that gap in there. Okay. The other thing here is that all the sides of a polygon are going to be straight. Right? Three straight sides. All right. And then it says a plane figure. What that means is that it can fit on a plane. It's not like a three-dimensional figure. So this right here would not be a plane figure because it's three-dimensional. And then it says it must have at least three sides. Okay, so the poly usually means many gone sides. Another example of something that would not be a polygon would be this, if it had like a curved side. Okay. Now we have these two words, concave and convex. You probably do not know what concave is, and you probably don't know what convex means. Concave means, I'll give the definition in an easy way, and then I'll give you your mathematical definition. Here's an example of a concave polygon. Notice it has like a little cave right here, okay? And a convex one would be one that does not have a cave. Now the mathematical definition of concave versus convex, concave, you can connect any 2 points, any 2 vertices, and it'll never fall outside of your figure. Now with a concave one, there will be a time where you will connect one vertex with another and it'll go outside of the figure. That is your mathematical definition. But your just normal definition would be a concave figure has a little cave, and this one is convex, the one that does not have a cave. Okay. Next thing we have here is equiangular and equilateral. This one has two parts to it. Equa means the same, and then angular, obviously angles. This is a polygon with all congruent angles. And then we have equilateral. Equa meaning the same. Lateral is talking about like the sides. So a polygon, I'm being lazy, I'm doing that instead of writing a polygon, with all congruent sides. Now, unlike a triangle, where if it has all congruent angles, then it's definitely all congruent sides, with other figures, other than three-sided figures, you could have all congruent sides and it wouldn't necessarily have all congruent angles. Okay, it's not guaranteed to have the other if it has one. With triangles, it is, but triangles are special. Now, if it does have all congruent angles and all congruent sides, it's called regular. So all congruent angles and sides. That's what it means by regular. All right, now if we go over and scroll down, let's see what we have here. This is talking about interior angles versus exterior angles. Interior angles are all of the angles on the inside. Okay, those are interior angles. Now, how you can find an exterior angle is you basically just go over and extend all the sides out. On each one of these, you will have a straight angle, and then you will have the exterior angle. A straight angle, and then an exterior angle. A straight angle, and an exterior angle. Straight angle, exterior angle. Straight angle, exterior angle. So basically, it's the angle outside if you extend out a side, and we're not talking about the straight angle. It's the other one. That would be considered an exterior angle. All right? So what we're going to do is we already know that if you have a triangle, the sum of the interior angles is 180 degrees. Okay, that's just a guaranteed fact, right? What we're going to do now is we're going to be looking at a 5-sided figure or a 6-sided figure or something like that, and we're going to find out what is the sum of the interior angles of that thing, because it might be handy for us to know. Is it always 180? What's it going to be? Okay, so in our little activity, we know that a triangle is 180 degrees, right? If we go over and look at this chart right here, it says, go ahead and draw a quadrilateral. So quadrilateral means 4 sides. There's a 4-sided figure. Then it says draw a 5-sided figure. There's a 5-sided figure. And then it says hexagon. Hexagon has 6 sides. Now we are going to use the fact that we know that a triangle is 180 degrees to somehow figure out how many degrees the inside of these other figures are, the interior angles. And how we're going to do that is I'm going to go over and start at any point, and I'm going to go to all other vertices. Start at one point and go to all other vertices. Start at a point and go to all other vertices. Now here's the concept. This thing has 4 sides, and then if I asked how many triangles can I create in there, that would be 2 triangles. This one has 5 sides, and I can make 1, 2, 3 triangles. This one has 6 sides, and I can make 1, 2, 3, 4 triangles. You might be asking yourself, what in the heck are you doing, Gallagher? Why in the world would we go over and make triangles inside? Well, look, if we make triangles, all of the interior angles are accounted for by the angles of the triangles. So this angle over here is accounted for by those two. That is accounted for. They're all accounted for. What does that have to do with anything? Well, we know this triangle is 180 degrees, and we know this one's 180 degrees. So 180 degrees and 180 degrees, that means that it's 360 degrees for a 4-sided figure. This one, all of the interior angles of our pentagon are accounted for. And that is going to be 180 degrees, that's 180 degrees, and that's 180 degrees. If we go over and do 180 times times 3, then we would get, let's see, 180 times 3, I believe is 540. Okay. Now, the next one that we're going to do, and I am going to, let me go ahead and get my calculator going on my phone. Calculator. Take me just 1 second. Calculator. If only Alexa was in here and I could just ask her to do it for me. All right, I got my calculator. Now on this one, we have 4 triangles. Each triangle is 180 degrees, as we know, 180, 180, 180. Altogether, 4 times 180, 4 times 180 is going to be 720. So now we know a hexagon, the sum of all the interior angles is going to be 720 degrees. Now, one thing you got to be very careful with is some people go over and I say, how many triangles can you make? And they go, well, I can make 4 for a 4-sided figure. Now, the problem with this is look at all of these angles here that are going to be part of the triangles but have nothing to do with the interior angles of the figure we're talking about. That's why I went over and I started at one place and I went to all the vertices. That way, these angles of the triangles have to do, they add up to be that angle of the figure. That angle of the triangle is part of the quadrilateral, and those 2 make up the other one. So therefore, if we add up the angles of the triangles, then we end up getting the sum of the interior angles of our figure here. Okay? Now, if we wanted to try to figure out a pattern here, If it has 4 sides, you'll end up with 2 triangles. If it has 5 sides, you'll end up with 3 triangles. If it's 6 sides, you'll end up with 4 triangles. If we wanted to make a formula for any figure with a certain number of sides, how would we do that? Well, I would go over and write out it in words. It seems like it is the number of sides minus 2. That tells you how many triangles there are. And then we know each triangle is 180 degrees. So that is what it's going to be, okay? That's your formula. If you want to get the sum of the interior angles of any figure, you would take the number of sides and subtract 2. That would tell you how many triangles. How many triangles? And then I multiply by 180 degrees for each triangle. So if you had a 100-sided figure, you would go 100 minus 2 times 180, and that would tell you the sum of all the interior angles. If you had a 5-sided figure and you wanted to know that one plus that one plus that one plus that one plus that one, 5 minus 2 tells you how many triangles times 180. Okay? Don't actually go over and make triangles for all your figures, because now we have a formula you can use. That's your formula. All right? Hopefully that makes sense. We already knew a triangle was 180 degrees, we just didn't know what the other ones were. So let's go ahead and do some practice problems. I believe before we do the practice problems, we need to be able to talk about different figures. So the way that we talk about different figures is by the number of sides. So we know a 3-sided figure is a triangle. We know a 4-sided figure is a quadrilateral. You know a 5-sided figure is a pentagon, like the Pentagon in Washington. 6-sided is hexagon. This one is a septagon or heptagon. You'll see both of those words used. 8-sided is octagon. I used to have a class that called it a stopagon because it's the stop sign, but it's an octagon. 9 sides is nonagon. 10 sides is decagon. 11 we call an 11gon. 12 is a dodecagon. Now I'm sure there is a real name for a 13-sided figure, 14, 15, and so on. These are the only ones I want you to memorize the real names. Anything other than these, you can just say the number of sides gone. So a 20-sided figure would be a 20gon, 21gon, and so on. So n sides is an n-gon. 31 sides, 31gon. These are the only ones I want you guys to memorize the real words for, or the real names. So if we were looking at something like this, sum of the interior angles of an octagon. Octagons have 8 sides. Rather than drawing it out and trying to figure out how many triangles you can get, I would just say octagon 8 sides minus 2, we're just using our formula, times 180. That's 6 times 180, and that gives me, it's 1080, but let me check on my calculator. 6 times 180 is 1080. So that means all of the angles together are going to give me 1080. All right. Remember, how does this work? That tells me how many triangles would be in there, and each triangle is 180 degrees. What is the sum of the interior angles of a decagon? Decagon is 10. 10 minus 2, that's my formula, times 180. 8 times 180 gives me 1440. If you made a 10-sided figure and you wanted to add up all the interior angles, you would end up getting 1,440 degrees. How about a 14gon? You're figuring this out. 14 minus 2 times 180. 12 times 180. 2160. Okay, now I want you guys to try this one. The sum of the interior angles of a hexagon. Hexagon is 6 sides. Figure out what that's going to be. 6 minus 2 times 180. 4 times 180. 720 degrees. Okay, now this is where it gets slightly more confusing. This is saying what is a single angle? So now we don't want to know all of the angles. I just want to know what is one of the angles of a regular heptagon. Okay, let's do a different one just so that it is going to be octagon, so that the number comes out nicely. Okay. Okay, so when we look at this, what it's going to be is normally we wouldn't be able to figure out what one of the angles is. We could only find out the sum of all of them. Let's just find the sum real quick. 8 minus 2 times 180. 8 times 2, 8 minus 2, that would give us 1080. Now, normally, we would have no idea how that's split up. Maybe one angle is really big and one's really small, and we wouldn't know. But since they told us it's regular, that means all the angles must be congruent, which means all we have to do is take the sum of all of them and divide by the number of angles. The number of angles is the same as the number of sides, which is 8. That gives me 135 degrees. Once again, if we had a regular octagon, looked like this, regular, meaning all the angles are congruent. We know the sum is 1080. And the reason why I can go over and just divide by 8 is because I know if it's regular, all of them are going to be congruent. Okay, that's how I divided by the number of sides. Go ahead and try this one. What is the measure of a single angle of a regular nonagon? And by nonagon, let's change it to be decagon, just so that the number comes out nicely. All right, you should have said 10 minus 2 times 180 is the sum, and then I would divide by 10 because there are 10 angles. So you should have gotten, let's see, 8 times 180 divided by 10. You should have got 144 degrees. The only reason we can do that is because we know all the angles are congruent. Otherwise, one angle could be big, one could be small, and so on. All right. All right, so that is the sum of the interior angles. It is just n minus 2 times 180. You just use that formula. Sometimes they ask you for a single angle, but many times it's just asking you what is the sum of all of them together. The only time you can really find a single one is if you knew they were all congruent. Now what we're going to do is we're going to move on to the exterior angles. So we want to know what is the exterior angles of a 5-sided, what's the exterior angles of a 6-sided, and so on. So give me just 1 second so that I can come up with the number that I was looking for. Okay, so let's assume that all of these angles are 108 degrees. 108 degrees. Okay, and then on this one, let's say that is 80 degrees. This one looks like 60 degrees, and then what is left over? 40 degrees. And this one is going to be, these are going to be 135 each, and so on. So what we're going to do is let's figure out what the sum of the exterior angles are. So let's figure out what each one of the exterior angles is. So what's left over here is going to be 72 degrees, right? Because it's a linear pair and 108 is already accounted for, so there's 72 left. Which means this 72, that 72, that 72, and that 72. Let's find out what 72 times 5 is. 72 times 5 is 360. Okay, so we're going to have to figure out what this is. A 5-sided figure is going to give you 360 for the outside. Okay, let's find out what it is for a 3-sided so we can make our formula. This is 40, there's 140 left over. If that's 60, there's 120 left over because it's a linear pair. If that's 80, then this is 100 left over. When you add all those up, you get, what the heck? A 3-sided figure is 140 plus 120 plus 100 is 360. What the heck? Let's check this one. 135, what's left over? 45 degrees. And there's going to be 8 of those. So what is 45 times 8? 45 times 8 is 360. That's weird. What's a formula that makes it so if it's a 5-sided figure you get 360, 3-sided figure you get 360, or 8-sided figure you get 360? Well, it's no formula at all. No matter what number of sides you have, you will always have 360 degrees for the exterior angles when you add them all together. That's the difference. The inside requires a formula. The outside of any figure is 360. And the reason for this, I don't know if I can draw it. Let me see if I can draw it. So if we went over and we're looking at a triangle, and then I kept going over and making the triangle smaller, at some point, take a look, as the triangle got smaller and smaller, I wasn't changing any of the angles, you end up just getting this. All of the exterior angles together make a circle. A circle is 360 degrees. Okay, so let's keep on cranking. Running low on time here. Okay, so let's go run through this real quick. The sum of the exterior angles with 100 gone is 360. The exterior angles of a regular pentagon, sum 360. The measure of a single exterior angle of an octagon, well, you know all of them together is 360, and how many exterior angles do you end up having? 8 of them. Divide by 8. 360 divided by 8. 360 divided by 8 equals 45. Because I know that they are all congruent because it's regular. Okay, and then we'll skip this one. So make sure you guys understand the difference between interior and exterior. Interior, you need a formula. Exterior, you do not. Okay, now just to finish these up really quickly. On a problem like this, if you were trying to find out what the missing angle was, what you need to do is first find out the sum. Well, it's 1, 2, 3, 4, 5. 5 sides. So 5 minus 2 times 180. That gives me 3 times 180, which I believe is 540, but let's just check. 3 times 180 equals 540. Okay, so we know altogether they are 540. Now let's take 540 and subtract away 90, subtract away that one, subtract away that one, and subtract away that one, and see what we end up having. So 540 minus 90 minus 110 minus 120 minus 150. That gave me 70 degrees left over. I did the sum of all of them, and I started subtracting away the ones they already gave me. On this one, we have 1, 2, 3, 4 sides. 4 minus 2 times 180 gives me 360. I know all of them together are 360. Let's subtract these away from 360. 360 minus 120 minus 85 minus 53. It gives me 102 left over. 102. Now I want to do one last problem. Let's say we had this. 2x, 3x, and 5x. If we wanted to solve for this, we would add all these together. So we would have 2x plus 3x plus 5x. But what would we set it equal to? Would we set it equal to 180 because it's a triangle? Well, it is exterior angles. Are the exterior angles of a triangle add up to be 180? Ah, it's 360. So then you'd have 10x equals 360. You get x equals 36. So be very careful, especially with this one, because triangles, you are so used to saying 180. It's 180 for the inside, but it's 360 for the outside. right? All right, let's go ahead and wrap this up. The sum of the interior angles of a polygon with n sides is, we know there's a formula, n minus 2 times 180. How did we do that? That tells us how many triangles you would be able to fit inside of the figure, and that is 180 degrees for each triangle. The sum of the interior angles of a polygon with n sides, exterior, sorry, not interior, is just 360 degrees. Hopefully that made sense. Sorry for such a long lesson today. Um, and just a little reminder, if they give you a figure like this, you know you can add up all the angles and set equal to what the sum is. And the sum, if it's an interior, can be found use the formula. If it is exterior, the sum would just be 360. All right, thanks for watching.